Hello everyone, hope you are doing well. So in today's video, I'm actually going to go through the 2020 Maths Methods VCA Exam 1. So yeah, let's get started. Okay, question 1 says, let y equals x squared sine x and find dy dx. So 1 mark, okay. So this is going to be nice and easy. So it's going to be dy dx is equal, this is your u in v. So u is x squared, v dash is cos x, plus v, which is sine x, multiplied by u dash, which is 2x. Now, pretty much oversimplifying this, so I'm just going to put this on top of here, nicely over here. Write your expression dy dx, so it'll be x squared cos x plus 2x sine x. Perfect. Evaluate f dash of 1 where f is this. Okay, so f dash of x is 2x minus 1 e x squared minus x plus 3. And f dash of 1 is 2 minus 1 e 1 minus 1 plus 3, which is e3. Done. Alright, question 2. A car manufacturer is reviewing the performance of a car Model X. It is known that any given time, 6-month service, the probability of a Model X requiring an oil change, so oil change, is this, and the probability of that Model X requiring an air filter change is this, and the probability that the Model X requiring both is this. So, state the probability, okay, so we want to state the probability that at any given 6-month service, Model X will require an air filter. So, let's say filter, let's say F, air filter without an oil change. So intersection, not an oil change. So I'm just going to draw a nice probability table here, because this is easy with doing it like this. Okay, so I know, let me just finish this off like that. Okay, and should be 1 over here. Let's say this is oil, not oil, and this is filter, not filter. So we know that an oil change is 17 over 20, and we know that the air filter is 3 on 20. And we also know both of them is 1 over 20, and we want to find F intersection O, which is this value here. So it is 3 on 20 minus 1 on 20, which is 1 on 10. Very nice and easy. A car manufacturer is developing a new Model Y. The production goals are that the probability of Model Y requiring air filter oil change at any given 6 months is this. The probability of Model Y requiring an air filter change is this, and the probability that Model Y requiring both of them is this, where m and n are positive integers. Determine m in terms of n if the probability of y, so probability of y requiring an air filter change, so let's say F air filter without an oil change, is 0.05. I'm just going to write this. I don't like it in decimals. I'll write it in fractions. Much easier to work with. And okay, so it's the same, pretty much it's the same principle. So just let me copy this. It's the same question, but yeah, just different. Let me just copy that, put it over here. Alright. And this just delete some stuff. So this is not what I need. I don't need this. I don't need this. And I don't need that. Okay. Okay, we know that it requires an oil change at this. So M plus N. And it requires an air filter at this. N plus M plus N. And requires both of them at 1 plus m plus n. Okay, and we want to find f, so this value over here, which is what? It's pretty much n over m plus n minus 1 over m plus n. It must equal 5 over 100. This can be written as n minus 1 m plus n over 5 100. And we can say that if we multiply this side by 100, multiply this by n plus n, we get 100n minus 100, 5m plus 5n. And we want to get, determine m in terms of m. So we want m as the subject. So that'll be 95n minus 100 equals 5m. So your m value is 19n minus 20. Is that right? So 95 divided by 5. 95 divided by 5. Okay, looks right, yep. Yeah, looks good, yeah. Alright, question 3 shown below is a part of the graph of the period of function of tan blah blah blah. Okay, so we don't know a and b, and we're given already 2 points. That's good. The graph is continuous from -1 to 1. Find the value of a and the value of b, where a is greater than 0 and b is between 0 to 1. Okay, not too bad. So this is just making 2 simultaneous equations. So let's sub in the first value. So -1 to 1 is, so that will create -1 tan. 10 negative a plus b. Okay, so inverse that. So okay, this is your first equation. Just say this is your first equation, and your second is 1√3, which is √3 tan a plus b, your second equation. And let's just make a and b. So if we, so tan -1 equals -a plus b, and we know that tan inverse of √3 is equal to a plus b. I know that tan of 1, so tan inverse of 1 is pi on 4, but it's negative. So -1, so negative pi on 4. So your equation 1 can become, it's going to be -a plus b, negative pi on 4. And √3, so √3 is pi on 3. So your second equation is a plus b, pi on 3. Yep, so is that right? So pi on 3, √3. Okay, perfect. So now, if we add both of these ones, so 1 plus 2, we'll get rid of the a. So it'll be 2b, pi on 3 minus pi on 4. So 2b pi, so it will be pi for a, so 12, so b must equal pi on 24, which is, so it's 0 to 1 between that. Perfect. Okay, now we know b. If we sub in b into, let's say, equation 2, so we'll say a is pi on 3 minus pi on 24. So 6, 12, 18, nope, 8, 16, 24. So this can be written as 7 pi over 24. These are your values. Nice. Okay. Alright, that's not a bad question. Next question. 4. Solve the equation this. Okay, this is very nice. So log 2x plus 5, take that squared in, minus log 2x plus 9 equals 1. Okay, log 2x plus 5 squared all over x plus 9 equals 1. 2 is x plus 5 squared x plus 9. That'll be 2x plus 18 x squared plus 10x plus 25. Yep. So, and that'll be x squared plus 8x, 25 minus 18, so that'll be 2 plus 7, so plus 7 equals 0. factorizing this, 7 and 1, it will be x plus 7, x plus 1, all equals 0. X is equal to negative 7 and x equals to negative 1. Now, you want to be careful because these two values, one could be actually wrong. And here's how. We need to double check these values if they meet the condition of a logarithm. A log function, the inside of any log must be positive. It cannot be negative. So how? Let's sub in the first value, negative 7. So we want x plus 5, the inside of that log, this value here, x plus 5 to be greater than 0. So let's try. If we put negative 7 plus 5, is it greater than 0, which is 5 minus 7 with negative 2. It's not greater than 0. Negative 2 is not greater than 0. So that solution is wrong. So we can actually decline that solution. What about x equals negative 1? Let's try that in both of them, both of these logs. So 5 minus 1, 4. Yep, that's positive. 9 minus 1, 8. That's also positive. So this one is good. So your final solution is x negative 1. That is your final solution. Very nice. Question 5. For a certain population, the probability of a person being born with a specific gene is this. The probability of the person having the gene is independent on the other. So we're using binomial distribution in a randomly selected group of 4. So n equals 4 people. What is the probability that there 3 or more people have this specific gene? Okay, so we want the probability as that 3 or more. So x is greater or equal to 3. Now let's say x is binomially distributed. So 4, 3 on 5. Okay, so this we'll write it as probability as x equals 3 plus the probability of x equals 4. Now, we know probability of x equals 3 is what? So it'll be 4, choose 3, 3 over 5, 3, 2 on 5, oh, yuck, what have I done? Okay, 2 over 5, 1, plus 4, choose 4, 3 over 5, 4, 2 over 5, 0. And so 4 choose 3 is what? So if I just draw a nice, so it'll be 2, 1, 3, 3, 1, 6, 4, 4, 1, 1. So 0, 1, 2, 3. So it'll be 4. So 3 times 9, so it'll be 27 over 1, 2, 5. 2 over 5 plus that'll be 4 choose 4 is 1. So 3 to the power 4 is 81, 625, and that'll be 1 anyway. So simplifying this further. Okay, so 27 times 2 is 50. Okay, so it'll be 54, yeah? So it'll be, wait, so 27 times 2 is 54, but we also must multiply that 54 by 2. Okay, so it's 52. Is that right? Have I done something wrong here? I don't know. Okay, so what I'm going to do is 4 times 2, 8. 27 times 8. Also, that's better to just do the other one. It's much quicker. So 27 times 4, 7, 14, 20, 28, 8, 9, 10. So wait, it's 108 actually. So, and 108 times 2 is 2, 116, yeah. So we add, yep, 2, 116, so 2, 116 over 124, so that'll be 625 plus 81, 625. 8, 9, so it'll be 297 over 625. Is that right? It's such a big number, but is this right? Let me just double check. I'm not too sure. So 27 times 2, so yeah, it looks right. doesn't look bad. In a random selected group of 4 people, what is the probability that exactly 2 people have this specific gene? Given, conditional probability. So we're saying the probability of x is equal to 2 given that at least one of those people have this gene. So x is greater or equal to 1. Which it can be, this simplifies to probability as x equals 2 all over probability of x is greater or equal to 1. Now, probability of x equals to 2 is what? Well, it's 4 choose 2. Probability of success was 3 over 5. 2 over 5. 2. Which will be, so 4 choose 2 is what? 0, 1, 2, 6. Okay, so there'll be 6 here. 9, 25. 4, 25. Yeah? So wait, 6. Okay. 9, 25, 4, 25. Okay, we got that. Okay, no, because we want it in this specific answer like this, I think the most safe answer we can do is we give it in terms of just like, we put the powers in there still, so it'll be still 6, 3 squared, 5 squared, 2 squared, 5 squared, like that, to be much safer. Okay, so, which simplifies to what? This simplifies to 3 squared multiplied by 2 squared. Oh, yeah. What did I do? Okay. Okay. So it simplifies to 6. 3 squared multiplied by 2 squared over 5 to the power 4. Okay. And then, what is the probability of x is greater or equal to 1? Which is just 1 minus probability of x equals 0. Yeah, so if 1's here, 1 minus probability of x equals 0, which is just 1 minus 4 choose 0. 3 over 5, 0, 2 over 5, 4 minus 0, so 4, which is, just say 2, 4, 5, 4, simplifies to 5, 4 minus 2, 4, all over 5, 4. And we have to divide both of them, so, okay, so, oh, it's so ugly, whatever, okay. Such a mess for that question. Such a big okay, so we divide them. So your probability of x is equal to 2 given x is greater or equal to 1 is 6, 3 squared, 2 squared over 5, 4 divided by, which just inverses it, so it'll be 5, 4 here. 5, 4 minus 2, 4. These 5 4s cancel out. Which gives us 6, 3, 2 minus 2, 2, all over 5, 4 minus 2, 4. Okay, looks 5, 4 and minus 2, 4 look right, but your A here, the top part, okay. Okay, wait. So, because they both have squared, we can multiply them inside and put that square outside. Yeah. And that'll be 6 inside, so the 6 will be inside anyway. And we're multiplying it by another 6, so it'll be 6 to the power 3. 6 to the power 3. 5, 4 minus 2, 4. Is that right? A and B. Yeah, it looks good. Yep, looks good. Such a hard question actually. It's so long. Question 2, from 0 to 2, where f of x is this, state the domain and rule. Okay, this is nice. Okay, your domain of f inverse is your range of your f. It's your range of f. So this is how it looks. Your f function would look like this. So your function would look like this. It would look like like this, and you have 0, 0 here, but we have a restriction here, so it's from 0 to 2. So let's say you just minus this part here and say it's closed over here, close bracket, and this part is 2, so this point over here is what? 1 over root 2, 1. So 2 on 1 here. So the range of f, so your dom of f inverse is, your range is from 0 to 1, all included. Nice. And to find your rule, so what we're going to say is let f of x equal y. Interchange f and y, so x and y. So that'll mean x 1 over root 2 root y. So now we solve for y. That will mean root 2x root y, squaring that, so it'll be 2x squared y. So now that means your rule, or just say, yeah, just write f inverse of x is 2x squared. Nice. Yeah, we've done it. So the graph of f of x is this. Yep. On the axis, sketch the graph inverse over its domain. Label the endpoints and the intersection with the graph of f. Okay, to just draw a inverse, we always just make sure to draw your y equals x. So this is nice. Yep. So points here. Okay. And we're just going to swap these 2 points. So it'll be 1, 2. So it'll be 1, 2, which is over here. And I'm just going to draw this nicely. I'm going to reflect it, so like that. And, oh, okay. Like that. Looks nice. Like that, perfect. Let me just sketch this out. Okay, something like that, perfect. And on the axis, sketch the graph of the domain, label the endpoint. So this endpoint will be 1 to 2. This will be 0, 0. This here would be half. Half. Point of intersection and give their coordinates. Very nice and easy. Find the area of the two regions. So find the area, total area of the two regions. One region bounded by f and f inverse of x, and the other region bounded by f and the f inverse and the line x equals 1. So I'm going to take a screenshot of this, and okay, so I'm going to take a nice screenshot of this, and I'm going to use this graph as to help me answer that question. Copy this. Alright, let's come here. 4 marks, okay. Let's paste this. Okay, so what we want is the area bounded. So from here, we want this area over here. This area. And from, so x equals 1, this line over here. We want this area. This area here. Okay, so it's not too bad. So what I'm going to do is, we already know the points of intersection, so let's just write the integrals. So the first integral will be from 0 to half, so 0 half of the upper fund, which is f of x. So I'm just going to write it as root x over root 2 minus your inverse, which is 2x squared, was it? 2x squared, yeah. 2x squared dx. And the other one is plus from half to 1. Now, 2x squared minus root x over root 2 dx. Okay. Okay. So, what I'm going to do is I'm going to just look at this. And let's say this over here, I'm just going to integrate it over here. So it's 1 over root 2 times x half. So I'm going to add 1, so it'll be x 3 over 2, and I'm going to means that divided by over 3 over 2, which will be the whole thing. If I, so imagine that 1 over root 2 divided by, so it'll be times 2 on 3, it's 2 over 3 root 2. So it means that 2 over 3 root 2 x to the power 3 on 2. So this will integrate to, well, okay, let me just rationalize it. So 2 root 2, 3 times 2, so take that 2, root 2 over 3, x 3 over 2. Nice. Okay, so let me just write it as that. Root 2, x 3 on 2, all over 3. Yeah? Okay. Minus 2x 3 over 3, 0 half, plus integral from 2x3 over 3, and we're just going to use the same because we already found this, minus root 2 x 3 over 2 all over 3 from 1 to half. Okay, simplifying this. Okay, so the first one is, say we put a half. Okay, let's say we put a half onto this function first. Okay, that x 3 over 2 can be simplified to what? It can be simplified to root x x3. So we're saying square root of 1 over 8, which is square root of 1 over 2 root 2. So this is being multiplied by root 2. These cancel out, so it'll be half. Half divided by 3 is 1 on 6. So this first value will be 1 over 6 minus, let me rub that out. Next one is, we'll put a half, so minus 2. That'll be 1 over 8. Negative 1 over 4 divided by 3, so times 1 on 3. 5, 12, negative 1 over 12. Okay, wait. Yeah. 1 over 12. Yeah, because I've already... What did I put in? So I put half here. But yeah. Looks right. Yeah. I don't want to put a second negative there. Okay. Minus... Now I'm going to rub this out. Now we're putting 1 here, so it'll be 2 on 3. Minus root 2 on 3. Wait, what am I doing? Oh my god, wait, what happened? Wait. I'm doing something wrong. What am I doing? Wait. Okay, think. That's such a long, okay. So I put the half in here, and I've got, okay. And I put the half in here, and I got this. Yes. So it's a minus, put those, that'll be 0. Okay. Close bracket. Plus. Okay, yeah. And then this one will be 2 over 3 minus root 2 over 3 minus, if we put a half, again, it's just 1 over 12. And the other one will be just minus 1 over 6. Because we've already done the calculation. Okay, let me just move this. Okay, something like that. Perfect. Just let me write this, minus 1 over 6. Minus 1 over 6. Something like that. Simplifying this, put a 12 there. 1 over 12 plus this over here is 2 minus root 2 on 3 minus so it'll be negative 1 over 12. Okay, that'll be plus half, plus 1 over 12 here, so it just changes to plus 1 over 12. Plus 1 over 12, which is 1 over 6 plus 2 minus root 2 over 3. Okay, which is 1, 6 here. Put a 6 over here. Plus 2. 2 minus root 2 all over 3. 1. So if I put a 1 here. Okay, which is 1 plus 4 minus 2 root 2 all over 3, which is 5 minus 2 root 2 all over 3. Is that right? In the form of A and B are positive, so A and B are positive integers. So 2 is positive. Yep, 2, 2. 6 is at the... Oh, wait. Oh, okay, wait. I made a mistake here. Yes, okay. This is supposed to be a 6 over here. 6s. Yeah, so because 6... I'm going to put it here, 6... Yeah, it's supposed to be 6 here. I forgot. Okay. Yep, looks right. Perfect. And we put units squared. Okay, nice. How many questions left? Oh, okay. 8, okay. 2 more questions left. Consider the function x squared plus 3x, this, and the point 1, 0. Where's 1, 0? So 1, what the hell? 1, 0 is over here. It's not on the graph. Part of the graph of f of x is shown. Show that point P is not on the graph. Okay, it's easy. So, we know that if we put f1, the point, it should equal 0 if the point was there. But let's see. So we're saying that 1 plus 3 plus 5. So, equals 9. 9 does not equal 0. Because point P is what? 1, 0. Yeah, so f1 does not equal 0. Therefore, P does not lie on the graph. Not lie on the graph. Okay, next question. Consider point AFA to be the point on the graph. Just find the slope of a line connecting point P and Q. So if, okay, this is going to be a secant. So we're going to use the, okay, so, so if I sub in A into f of x, so f on A is what? So it'll be a squared plus 3a plus 5. So your actual point Q is the point a squared plus 3a plus 5. And point P is 1 and 0. To find this gradient, the slope is m. So 0 minus... Okay, if I put minus, so this will become 0 minus, will be minus a squared minus 3a minus 5 all over 1 minus a. Yep, so 0 minus the whole function over here, which is, yep, over 1 minus a. That's your slope. Next question, find the slope of the tangent to the graph of f at point Q. So, to find the tangent, so what's f dash of x? It'll be 2x. I know it's 2x plus 3. So f dash of the point Q, which is a, is 2a plus 3. Your gradient is, yeah, 2a plus 3. That's your slope. Let the tangent to the graph of f... Wait. Let the tangent to the graph of f at x equals a pass through point P. Find the values of a. Okay. So we don't know, okay, we don't know a, but it passes through point P. So P is again 1, 0. So what we can do over here is we already know that the gradient of a is something like this. Because a we don't know, but we know that the gradient is this. So we can say, because it passes through this point, we can say y minus 0 equals your gradient. Wait. The tangent passes. Okay, yeah. y minus 2a plus 3 x minus 1. So solving that, we just want to find the values of a. So okay. Wait, tangent to the graph of x plus find the values of a. So wait, okay. Wait, let the tangent to the graph of f at x equals a pass through the point this. Okay, wait. So, okay, a is q, just a is q in this term, so the coordinates of q is what? A squared plus 3a plus 5. And it means that f dash of x is, what was it? 2x plus 3. So f dash of x, a, is 2a plus 3. So y minus a squared plus 3a plus 5 is equal to 2a plus 3 x minus a. So now I know this point lies into it, so I'm going to sub into the x and y. So this will be 0. A squared plus 3a plus 5 equals 2a plus 3. 1 minus a. Expanding this, negative a squared minus 3a minus 5. 2a minus 2a squared plus 3 minus 3a. Okay. This will be a squared if I bring that 2 in the front, because it'll be 2 minus a minus 1, yeah. So it'll be that. So these cancel out. Okay, these also cancel out anyway. If I bring that 2a, so it'll be negative 2a over here. And negative 5 minus 3 equals 0. A squared minus 2a, 5, 6, 7, 8, minus a equals 0. That simplifies to a, so factorize that, 4, 2. So 2 minus 4, negative 2, okay, so it'll be a minus 4, a plus 2 equals 0, where a is equal to 4 and a equals negative 2. Yep, so find the values, these are your values. Okay, that was not bad. I just was so confused with that one. Equals negative 2. Done. Give the equation of one of the lines passing through the point P that is the tangent to the graph of f. Wait, give the equations of one that passes through the point. Okay, yeah, just sub in one of those values then, of a, 4 or negative 2. So, we already know the equation of the line is y minus, okay, it's a squared. Let's do the easiest one, which is I'll do negative 2. So that'll be here 4 minus 6 plus 5 equals 2 times 2, so negative 4 plus 3 x plus 2 y. Okay, so 9 minus 6, which is 3, so it would be y minus 3. 3 minus a negative x plus 2. Y equals negative x minus 2 plus 3. Y equals negative x plus 1. Okay, that's one of the equations. 3 minus 2, yep, 1. Okay, find the value of k that gives the shortest possible distance. Wait, find the value of k that gives the shortest possible distance between the graph of the function y equals f x minus. Okay, so x minus k, that k value is a translation to the right or left. Because, okay, so it's just translation right or left. And so find the value that gives the shortest possible distance between the graph of the function this and point P. Well, okay, let's look at it like this. So let's say point P is here, yeah? And this is a quadratic. And I know that it has some turning point over here because, yeah, so it's a quadratic. And we want to find the shortest distance. And remember, it only can translate right or left. That value of k only translated right or left. So, what does that mean? So think of it like this. Imagine this graph of here. We want to find the shortest distance. So if we take this whole graph and we move it, let's say we find the turning point. Let's actually just find the turning point. Wait, no, don't bother with that first now. So what we want to do is, let's say the shortest distance is translating it to the right, by the way. So if you translate it to the right as some value, and we bring it over right over here. Perfect. This over here is pretty much the shortest distance. It is the most closest and it's the shortest distance. So knowing that, that's good. So let's just try to find the turning point of the function. Okay, f of x, what's f of x? So f of it is x squared plus 3x. What's it? X squared plus 3x plus 5. Okay. To find the turning point, we're going to just do turning point form. So, okay. So I'm going to say x squared plus 3x. So we know b over 2 squared. So 3 over 2 squared, 9 over 4. So we're going to say plus 9 over 4 minus 9 over 4 plus 5. That's x plus 3 over 2 squared. And that will be plus 20 all on 4. 11 over 4. 20 minus, okay. 11 plus 11 over 4. So this is your turning point, which is negative 3 over 2, 11 over 4. Negative 3 over 2, 11 over 4. So this turning point here is negative 3 over 2, 11 over 4. It means to make, so and we know this value is 1 or 0. And so this distance to this distance is pretty much what? 1 minus, so 1 minus 3 over 2, which is 1 plus 3 over 2. Okay, so what's 1 plus 3 on 2? 5 over 2. Your value of k is actually 5 over 2. Not too bad. This question was actually not too bad. It was not too bad. Yeah, it's actually a good question. Like, it was very easy. That's good. Like, it wasn't too hard to understand, yeah. Okay, that's that. Last question. Alright. I'm so tired, dang. Okay. Part of the graphs of y equals f of x is here. Okay. And where f is from 0 to infinity and f of x is this, is shown below. The graph has a minimum value at point q a of a is shown. Find the coordinates of q. Okay, so let's find f dash of x first. F dash of x is what? If that's u, that's v. We're saying x, 1 over x plus log e of x, 1. So, which is 1 plus log e of x. Yep. And we want to find the coordinates q, so we're going to let f dash of x equals 0. Therefore, we're saying 1 plus log e of x equals 0. That'll be log e of x equals negative 1. E negative 1 equals x. So x is actually 1 over e. Now subbing 1 over e to f of x, 1 over e is... Okay, so it's 1 over e log e. So 1 over e is just e minus 1. Bring the minus there, and that cancels, so it'll be just negative 1 over e. So coordinate q is 1 over e, negative 1 over e. Yeah. Okay, that's good. That's the right question. Because normally the last questions is gonna be the hardest one, so I'm already tired. I'm already getting to the challenge. Using dy, okay, this looks like straight away a recognition integration. So using dy dx, this show that the x log has an interderivative of this. Okay. No, okay. So what we want is this over value here. So we want just this value over here. So if we move it around, so we can say d dx of x squared log e of x all onto, oh no, so that, so d dx that minus x all over 2 is equal to x log e of x, yeah? And it means to find the antiderivative of that, so to find the antiderivative of x log e of x dx, we can take the half, so we're trying to find the antiderivative of d dx, x squared log ex minus x dx. Half, this d dx cancel out, so it'll be x squared, x squared log ex minus x squared on 2. Yep, and we multiply them all by half. That will be, just move this up. Something like that. Multiplying that all by half, so your x log e of x dx is x squared log e of x all over 2 minus x squared on 4, which is the same as the answer here. Okay, find the area of the region that is bounded by the f and the line x equals a. Okay, so we're trying to find this area over here. Yeah, so find the area of the region that's bounded by the line x equals a, and the horizontal axis for x is equal to, from x is from a to b. Yep, wait, find the area of the region that is bounded by the graph of f and the line x equals a, yes, and the horizontal axis from x is an element from a to b, where b is an x-intercept of f. Yeah, but yeah, we just need to find this. Why do we care about b anyway? They're just telling us to find this. It's trying to tell us this over here because it tells us that the line x equals a. Yeah, okay. So let's do that. So what we're saying is we want to find the integral from 0 to a. So 0. We want to put a negative because it's negative area. So 0 to a, but our a value is our maximum, which is we found over here, which is 1 over e. So 1 over e of the function f of x, which was x log e of x dx. Okay, now that's easy because it's just negative. So we already know what the integral of x log ex is that. So it's this one over here. Minus x squared over 2. 1 over e, 0. Simplifying this, we get 1 over e squared. We'll put a negative here because that log e, and we'll put it in here, yep. All over 2 minus, so 1 over e squared divided by 2, so half, minus 1 over 2e squared. Okay. All minus, we'll put a 0, 0, yep, 0. Let's simplify this more. So it'll be negative. So negative 1 over e squared divided by 2, so it's times half. So it's 1 over 2e squared minus 1 over 2e squared. Okay, so it's just 1 plus, so it's 1 over e squared. Yeah? So it'll be negative 2e squared. These cancel out. And then there's negative. So yeah, 1 over e squared. That's your area. Done. Units squared. Okay. Yes, last question. Okay. Let g be from a to infinity, where g of x is f of x plus k. So there's a k value that translates up and down of f of x. And that's your g. Find the value of k for which y equals 2x is a tangent to the graph of g of x. Okay. We need to find the value of k where that is. Okay. So what we're trying to find is, this is what I think they're trying to tell us. They're trying to tell us y equals 2x must be a tangent. So this is y equals 2x, right? So it passes through 0 to 0 and it's like this. That's your y equals 2x. Okay. And this is your graph of f of x. And because it's been translated k units upwards, it will look like this. So what translation does it make it the graph have a tangent? So if we go up, so some translation up, perfect. And some point here, over here, some point over here, it will have a actual tangent. No, it will have a point of intersection. Yeah, is that what it says? Yeah, it'll become, if it has a point of intersection at that point, it means it will become its tangent. Y equals 2x. Okay, how am I going to find k? So, okay. If I bring this graph down here. Okay. Because this over here, this graph over here, we can pretty much translate it down. It doesn't change its gradient because it's gradient still. And we can maybe hit it to the point where it touches the value over here. And we can find that value. Yeah, so okay. So we know f of x, and we know that the gradient is 2x. So if we let it equal to 2, the gradient, we'll find the value of this intersection. And now we know that point, we can make an equation with it. We can actually make an equation and find the y-axis over here, like where it crosses that y-axis. And knowing that y-axis, knowing that y-axis, we can actually just bring it back to 0. Like, okay, say it was here, yeah? And let's say y equals, so let's say this over here is, so y equals -2. It means that if this graph went back, like it was normally back, and this was translated some units, blah, 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 and it was still tangent, this translation up is the same as this over here, which will give us our value of k. So yeah, that's a way to do it. Let's do it that way, actually. So what we want to do here is, okay, so we know that the gradient's 2, so we can say f dash of x, which is f dash of x is 1 plus log e x. Yep, so 1 plus log e of x. Okay, 1 plus log e of x. And we know the gradient's 2, so 1 plus log e of x equals 2. So log e of x equals 1, e equals 1, x, e equals x. So it means that this value over here is, this point over here is e, some value, so it'll be e, and if we put it on 2e, so e, that's that point. Now, we know that the gradient, so we can just say y minus 2e equals 2x minus e. So y equals 2x minus 2e plus 2e. Okay, wait. But these also cancel out. What the hell have I done here? Wait, what have I done? I'm so confused. Wait, so I've got the gradient. I've got the gradient. And I found that point. Wait. if I know that point here is E, okay, this point, that point of intersection is E. All right, and okay. If I look, wait, let's put that E into the function E log E. Okay, it still becomes 0. So E on 0. Okay, wait. It's E on 0. Wait, E on 0. That's your actual. So what did I do wrong? Over here. Wait, if it's E on 0, let's try that. 1 minus 0 equals 2x minus E. So y equals 2x minus 2e. So your value here is minus 2e? I'm still confused here. I'm actually confused. Wow. This, I fully understand what I'm doing, but it's actually a confusing question because... Okay. Find the value for y equals 2 is a tangent to the graph of this. It's only 1 mark. Find the value of k. Okay. So, let me just nicely rub this off. So we have this tangent, okay. This tangent, that's... So let's say this is y equals... Wait. This is y equals... Oops. Y equals 2x over here. Aha, I see what I was doing. If I was letting the gradient of that, and it was giving me this point over here. And it was, so if I take this and it was giving me this point over here, some point over here. Which was E, yeah. So this point, some point over here is E. And if I shove it back into the equation, 2e, like, this is y equals, 2x plus some value. Okay, wait, I see what I was doing wrong. Okay. Because we don't know that c value, why am I, okay, I see what I did wrong. Okay, so if I put that e actually into the function f of x, so f of e, we get e log e of e, which is just e. Yeah, so it'll be e. So e on e, actually. What the hell? Is that right? Right, e. Put an e in there, that'll be 1. Yeah, so log e on e. So now, we know that the gradient's y equals 2x, so we can say y minus e equals 2x minus e. So y minus e equals 2x minus 2e. Y equals 2x minus 2e plus e. Y equals 2x minus e. 1 minus, yeah. So this here is minus e. Is that right? Yeah. And yeah, so if we translated it up units, we would get, yeah, so minus e, just make it plus e. That should be your value. K equals e. I hope that's right. Wait, k plus e. So what we're saying is, if I have this graph over here, okay, and we translate it, all of this, just here, translate it, let's say e units up. Oh yeah, no. We're supposed to translate this one here. So we translate it up 3 units, e units up, so it'll be like this. And it means that this over here will also translate e units up. And it's still perfect, yeah. Alright, that was a pain. Last question. Find all values of k for which the graph of g and the inverse do not intersect. Okay, what is this? So we want them to not intersect the graph of g and the inverse. So, okay, let's say, okay, this is the graph of f, yeah? And so it's nicely like this. its inverse would be, if I draw y equals x, say this is y equals x. Its inverse will look like this. Something like, something like that, like that, like that, something like that. So something like that. Okay, so if we because it translates up and down, let's say we translate the down, like let's say k is less than 0, what happens to our graph? So if we translate it down, so let's say goes down, what would happen? This over here would go to the left. But in any way, even if you took this to the thousands of left, it will still intersect the y equals x graph, which means that it will also intersect our graph also. So no, that doesn't work. So putting it down, like k is less than that, does not do any good. What else can we do? What about we put k is greater than 0? Say k is greater than 0. Oops. K is greater than 0. Okay. So we put it like up this units. It means that this one over here will go up. Oops. It's supposed to go like up, like this. This unit, somewhere like that. Okay. If I take this a little bit more, and it touches a little bit on the graph of the y equals x, even this one over here. Wait, because I was going to the right, so this one has to go up. Yep. They would hit at one point, this point over here. Which means that, yeah, so it will give us a value of k. Let's say we find that value of k. It means that k is greater than that value we find. Yeah, because if we go more than that value, we would actually they would never intersect, because this graph over here would go like forever up, and the other one here will go like this way. So it will never intersect again. So knowing that, what can I determine here? Y equals x is our graph. How can I get the translation up? So, Okay, wait. If I know that this graph over here is y equals x, this orange graph is y equals x, and we find where the gradient of the f of x, so f of x, the gradient, which is what? 1 plus log e of x, where it equals that 1. So if we let it equal to 1, we'll find that x value. So log e of x equals 0, so e of 0 equals x, so 1 equals x. So if 1 equals x, it means this value over here is 1. 1, yeah. So we know that's 1. And if I shove it into the f of x, which is what? Log e of 1, which is 0. So let's say it's 1 on 0 here. It's saying 1 on 0. What? Wait. Okay. So x equals 1 is going to give us this gradient over here. Yes. It's x. Okay, so it's that. Yeah, okay. So give us that point. Now, at least we have that point. No, I see what I was doing. Yeah. Now, it makes sense. So this point 1 on 0, at least we have that point. We can at least now make an equation. So we can say y minus 0 equals x, or just 1. Actually, in terms of 1x minus 1. Y equals x minus 1. It means that your c value is, so if it's -1, it means it would go It means, yeah, so it means your value is, your k value must equal 1. Your k value must equal 1. So we said that k must be greater than 1. Yeah, because your k value, remember that k value, we found it's 1, yeah. So if it's greater than 1, so yeah, it cannot equal to 1, yeah, because they'll intersect at that point. Yeah, well, it's 2 marks, so yeah. Well, we can show some little bit more working out, like, find derivatives and stuff. Look, I'll be honest, that last question was such a... It was alright. It was not bad. It was just very confusing, most of it. Let me just take copy, cut that, paste it over here. Nice. Alright, find the values of k. K is greater than 1. Yeah, so I hope you guys enjoyed this video. This exam was not too bad. Had some long questions and like long algebra, I would say. The probability was probably like a meh, I would be honest. Like this one was actually quite confusing. Yeah. But the overall exam was alright. I've seen worse, so yeah. Hope you guys enjoyed this video. Make sure to like and subscribe, and please follow this channel for more videos. I will be making more, like I'll be making physics, chemistry, methods, and specialists. Yeah, hope you guys enjoy your day. Have a great day. Bye-bye.